Imagine you are in space. You pop open a flask of water, and instead of boiling, it does something completely unexpected. No bubbles, no steam, just poof, gone. What just happened? On Earth, boiling happens when water gets so hot that its molecules start breaking free, turning into steam. But that's only a half of the story. Boiling isn't just about heat, it's about the pressure. See, air pressure on Earth keeps water in liquid form, but in space, there almost no pressure. Which means, if you took a cup of water into space and removed the lid, it wouldn't just boil, it would explode instantly because without pressure, water molecules escape way easier. This is called boiling point drop. In fact, in space, water can boil at room temperature. No heat needed. It just turns into gas and disappears. But here's where it gets even weirder. If the water isn't inside a container, it won't just boil. It will also freeze at the same time. Why? Because in space, there is nothing to trap heat. The moment water molecules escape, they take heat away with them, and whatever's left behind turns into ice. Now, what if you try to touch it? Would it burn? Actually, no. Because it's not hot boiling, it's low pressure boiling. It wouldn't feel cold until it evaporates off your skin in seconds. Oh, and don't even think about drinking it. Without pressure, water won't stay down in your stomach. You would burp up steam, painful steam. So, yeah, boiling water in space isn't just weird, it's terrifying. Instant boiling, instant freezing, and absolutely no way to enjoy a hot cup of chai. But here's the real question. If boiling behaves so differently in space, what about the rest of our body fluids? What would happen if you were exposed to space without a suit?